Hello everyone, I am Amutha from Department of Mathematics, Nandha Engineering College. Today I am going to speak about one of the most powerful tools based engineering mathematics, that is matrices and their applications. So what is matrices? So the matrices is a rectangular arrangement of numbers in rows and columns. It represents linear transformation. Why it matters? Every system of linear equations, data sets and physical systems can be written as matrix. Let us see the key operations of the matrix. So first one, addition, subtraction, multiplication, inverse, transpose, rank, etc. So what are the types of the matrices? So first one is row matrix. So if a matrix having a single row is called row matrix, column matrix. So if a matrix having a single column is called a column matrix, null matrix. If all the elements are 0 is called the null matrix. Identity matrix. If the diagonal values are 1 other than the elements are 0 is called identity matrix. Scalar matrix. So determinant of A value is equal to 0 is called a scalar matrix. Symmetric matrix. A is equal to A transpose. The given matrix is called symmetric matrix. Non-symmetric matrix. A is not is equal to A transpose is called a non-symmetric matrix. Order of the matrix. So order of the matrix is number of rows and its columns is called order of a matrix. So next to see about characteristic equation. What is characteristic equation? For a square matrix, the characteristic equation is determinant of A minus lambda I is equal to 0. Here A is a given square matrix and lambda be a scalar and I be the identity matrix. Next to calculate the characteristic equation for 2 by 2 matrix, that is lambda square minus S1 lambda plus S2 equal to 0. Here S1 is the sum of the main diagonal element and S2 is the product of the matrix. For 3 by 3 matrix, the characteristic equation is lambda cube minus S1 lambda square plus S2 lambda minus S3 equal to 0. Here S1 is the sum of the main diagonal elements and S2 is sum of the minus of the main diagonal element and S3 is determinant of A. Next, what is the eigenvalue? The roots of the characteristic equation is called the eigenvalues. Next, to calculate the eigenvector, there are 4 types to calculate the eigenvector. So first one is symmetric with non-repeated, symmetric with repeated, non-symmetric with non-repeated and non-symmetric with repeated eigenvalues. Now let us see the Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation is called Cayley-Hamilton theorem. The uses of the Cayley-Hamilton theorem is to calculate the integral powers of A for a non-singular matrix and inverse value. Matrices are used in many fields like computer graphics, medical field, GPS and Google Map, weather forecasting, banking and finance, etc. As a conclusion, we can say matrices are the essential part of modern technology. Thank you.